Welcome friends in the video of Mathematics Class 10 NCERT Chapter 2 Polynomials. We shall cover this chapter under 4 main topics: Introduction to Polynomials, Geometrical meaning of the zeros of the polynomials, Relationship between zeros and coefficient of a polynomial, and finally the division algorithm for polynomials. So let's begin.
If you wanna go, then I'll be so lonely. If you're leaving, baby, let me down slowly. Let me down. Let me down.
Let me introduce you to polynomials. Let us quickly recall that in class 9th we have learned that if p of x is a polynomial in the variable x, then the highest power of x in p of x is called the degree of the polynomial p of x. For example, consider the polynomial 4x plus 2. Here, the highest power of x is 1, so the degree of the polynomial is 1. Similarly, if we consider another polynomial 2y squared plus 3y plus 4, which is a polynomial in the variable y, here the highest power of y is 2, so the degree of the polynomial is 2. Now, polynomials are divided into groups depending on the degree of polynomials. First comes the linear polynomial. Any polynomial of degree 1 is called a linear polynomial. For example, the degree of the polynomial 4x plus 2 is 1, and hence it is a linear polynomial. Again, if we see the polynomial 2y squared plus 3y plus 4, which is a polynomial in the variable y, is a polynomial of degree 2 and hence is not a linear polynomial. Then comes the quadratic polynomials. Polynomials of degree 2 are called quadratic polynomials. For example, 2x squared and 2y squared plus 3y plus 1 are some polynomials of degree 2 and hence are quadratic polynomial. Similarly, 2 minus y and 2y cubed plus 3y plus 4 are some polynomials which are not quadratic polynomials. In fact, any quadratic polynomial in x is always of the form ax squared plus bx plus c, where a, b, c are real numbers and a is not equal to 0. Now comes the cubic polynomial. Polynomials of degree 3 are called cubic polynomial. For example, the polynomials 2x cubed and 2y cubed plus 3y squared plus 1 are some of the polynomials of degree 3 and hence are cubic polynomials. And polynomials like 2 minus y squared and 2y squared minus 3y plus 4 are not cubic polynomials. More generally, any cubic polynomial in variable x is of the form ax cubed plus bx squared plus cx plus d, where a, b, c and d are real numbers and a is not equal to 0. Now, let us consider a polynomial px, which is 2x squared minus 3x plus 4. If we put x equals to 2 in the polynomial, we get 6 as the value of p2 at x equals to 2. Similarly, if we put x equals to 0, then p0 is the value of px at x equals to 0, which is 4. And in general, if px is a polynomial in x and if k is any real number, then the value obtained by replacing x by k in px is called the value of px at x equals to k and is denoted by p of k. Now, let us consider another polynomial gx, which is equal to x squared minus 3x minus 4. Now, putting minus 1 in place of x, we get g of minus 1 equals to 0. Also note that if we put 4 in place of x, we again get 0, as g of minus 1 is equal to 0 and g of 4 equals to 0. Minus 1 and 4 are called the zeros of the quadratic polynomial x squared minus 3x minus 4. More generally, a real number k is said to be a zero of a polynomial px if p of k is equal to 0, which means if we put any real number, say k, in place of x in the polynomial px and if the value comes 0, then we can say that k is a zero of a polynomial px. Now, if k is a zero of a linear polynomial px, which is 2x plus 3, then p of k is equal to 0 gives us k equals to minus 3 by 2. In general, if k is a 0 of a linear polynomial px of the form ax plus b, then p of k is equal to ak plus b, which is 0. That is, k equals to minus b by a. So, the 0 of the linear polynomial ax plus b is minus b by a, which is minus constant term upon coefficient of x. Now, let us see the geometrical meaning of the zeros of a polynomial. Let us first consider the linear equation ax plus b where a is not equal to 0. Now, the graph of y equals to 2x plus 3 is a straight line passing through the points minus 2, minus 1 and 2, 7. From this figure, you can see that the graph of y equals to 2x plus 3 intersects the x-axis midway between x equals to minus 1 and x equals to minus 2. That is at the point minus 3 by 2, 0. And we also know that the 0 of this polynomial is minus 3 by 2. Thus, the 0 of the polynomial 2x plus 3 is the x-coordinate of the point where the graph of y equals to 2x plus 3 intersects the x-axis. In general, for a linear polynomial ax plus b where a is not equal to 0, the graph of y equals to ax plus b is a straight line which intersects the x-axis at exactly one point, namely minus b by a, 0. Therefore, the linear polynomial ax plus b, where a is not equal to 0, has exactly 1, 0, namely the x-coordinate of the point where the graph of y equals to ax plus b intersects the x-axis. Now, let us consider a quadratic polynomial x square minus 3x minus 4. Let us see what the graph of y equals to x square minus 3x minus 4 looks like. In fact, for any quadratic polynomial ax square plus bx plus c where a is not equal to 0, the graph of the corresponding equation y is equal to ax square plus bx plus c has one of the two shapes, either open upwards or open downwards, depending on whether a is greater than 0 or a is less than 0. These curves are called parabolas. From the table, the zeros of the polynomial are minus 1 and 4. Also note from the graph that minus 1 and 4 are the x-coordinates of the points where the graph of y equals to x square minus 3x minus 4 intersects the x-axis. This fact is true for any quadratic polynomial, that is, the zeros of a quadratic polynomial ax square plus bx plus c where a is not equal to 0 are precisely the x-coordinates of the points where the parabola representing y equals to ax square plus bx plus c intersects the x-axis. From our observation earlier about the shape of the graph of y equals to ax square plus bx plus c, the following three cases can happen. Case 1. Here, the graph cuts x-axis at two distinct points, a and a dash. The x-coordinates of a and a dash are the two zeros of the quadratic polynomial ax square plus bx plus c in this case. Case 2. Here, the graph cuts the x-axis at exactly one point, that is, at two coincident points. So, the 2 points a and a dash of case 1 coincide here to become one point a. In this case, the x-coordinate of a is the only zero for the quadratic polynomial ax square plus bx plus c. And last, case 3. Here the graph is either completely above the x-axis or completely below the x-axis. So, it does not cut the x-axis at any point. So in this case, the quadratic polynomial ax square plus bx plus c has no zero. Now we have seen all the three cases geometrically, and we can now say that the quadratic polynomial can have either two distinct zeros or two equal zeros, that is 1 0, or no zero. This also means that a polynomial of degree 2 has at most two zeros. Or in general, given a polynomial p of x of degree n, the graph of y equals to px intersects the x-axis at most n points. Therefore, a polynomial p of x of degree n has at most n number of zeros. Let us now see the relationship between zeros and coefficients of a polynomial. We now know that the zero of a linear polynomial ax plus b is equal to minus b by a. that is minus constant term upon coefficient of x. Now consider a polynomial p of x, which is equal to 2x square minus 8x plus 6. Here by middle term factorization we can write it as 2 of x minus 1 into x minus 3. The value of p of x will be 0 when x minus 1 is equal to 0 or x minus 3 equal to 0. That is when x is equal to 1 or x is equal to 3. So the zeros of 2x square minus 8x plus 6 are 1 and 3. Observe that sum of its zeros is equal to 1 plus 3, which is 4, and 4 can also be written as minus of minus 8 upon 2, which is equal to minus of the coefficient of x upon coefficient of x square. Again, the product of its zeros, that is 1 into 3 is equal to 3, which can also be written as 6 upon 2, which is the constant term upon coefficient of x square. Let us see another example. P of x is equal to 3x square plus 5x minus 2. By middle term factorization, we can write it as 3x minus 1 into x plus 2. The value of p of x will be 0 when 3x minus 1 is equal to 0 or x plus 2 is equal to 0. That is when x is equal to 1 by 3 or x is equal to minus 2. So the zeros of 3x square plus 5x minus 2 are 1 by 3 and minus 2. Again, observe that the sum of its zeros is equal to 1 by 3 plus minus 2 is equal to minus 5 by 3, that is minus coefficient of x by coefficient of x square. And the product of its zeros, which is 1 by 3 into minus 2, is equal to minus 2 by 3, that is the constant term upon coefficient of x square. From this, it can be concluded that if alpha and beta are the zeros of the quadratic polynomial p of x of the form ax square plus bx plus c, where a is not equal to 0, then we know that x minus alpha and x minus beta are the factors of p of x. Therefore, ax square plus bx plus c is equal to k of x minus alpha into x minus beta, where k is a constant, which gives us k x square minus k of alpha plus beta x plus k alpha beta. If we compare the coefficients of x square, x and constant terms on both the sides, we get a is equal to k, b is equal to minus k of alpha plus beta, and c equals to k alpha beta. Now this gives alpha plus beta is equal to minus b by a, that is the sum of zeros, and alpha beta is equal to c by a, that is product of the zeros. Similarly, it can be proved that if alpha, beta and gamma are the zeros of the cubic polynomial ax cube plus bx square plus cx plus d, then alpha plus beta plus gamma is equal to minus b by a, alpha beta plus beta gamma plus alpha gamma is equal to c by a, and alpha into beta into gamma is equal to minus d by a. Let us now learn about our last topic, which is division algorithm for polynomials. If you are given a cubic polynomial and you know only one of its zeros, using this division algorithm, you can easily find the other two zeros. For this, let us first consider a cubic polynomial x cube minus 3x square minus x plus 3. And if 1 is one of its zeros, then we know that x minus 1 is a factor. Now we can easily divide x cube minus 3x square minus x plus 3 by x minus 1 to get the equation x square minus 2x minus 3. Now by splitting the middle term of x square minus 2x minus 3, we can get the factors as x plus 1 into x minus 3, and by this we get x cube minus 3x square minus x plus 3 is equal to x minus 1 into x plus 1 into x minus 3. Now all the three zeros are known to us as minus 1, 1 and 3. Now let us see what does division algorithm for polynomials actually state. It states that given any polynomial p of x and any non-zero polynomial g of x, there are polynomials q of x and r of x such that p of x is equal to g of x into q of x plus r of x, where r of x is equal to 0 or the degree of r of x is less than the degree of g of x. So this was the last topic of this chapter. Now let us quickly recall what we have studied in this video. We learned that polynomials of degrees 1, 2 and 3 are called linear, quadratic and cubic polynomials respectively. A quadratic polynomial in x with real coefficients is of the form ax square plus bx plus c, where a, b and c are real numbers and a is not equal to 0. The zeros of a polynomial p of x are precisely the x coordinates of the points where the graph of y is equal to p of x intersects the x-axis. A quadratic polynomial can have at most 2 zeros and a cubic polynomial can have at most 3 zeros. If alpha and beta are the zeros of the quadratic polynomial ax squared plus bx plus c, then alpha plus beta is equal to minus b by a and alpha beta is equal to c by a. If alpha, beta and gamma are the zeros of the cubic polynomial ax cubed plus bx squared plus cx plus d, then alpha plus beta plus gamma is equal to minus b by a, alpha beta plus beta gamma plus alpha gamma is equal to c by a, alpha into beta into gamma is equal to minus d by a. And finally, the division algorithm, which states that given any polynomial p of x and any non-zero polynomial g of x, there are polynomials q of x and r of x such that p of x is equal to g of x into q of x plus r of x, where r of x is equal to 0 or the degree of r of x is less than degree of g of x. And by this, we have completed our chapter polynomials. If you have any doubt in the video or in the chapter, let me know in the comment section below. Also, don't forget to subscribe and stay tuned.